Given 170 degrees, give the exact measure and its approximate value to the nearest hundredth. So this is sort of what we were doing before. Now there's a couple of ways of converting from degrees to radians and whatnot. If you've forgotten all the methods, this is what I would suggest. Start with what you know. You know that 180 degrees, if we put degrees on this side, is equal to how many radians? Pi. If I want to find 170, can you see that you could find out what 1 degree was by dividing by 180, and then figure out what 170 degrees is by taking 1 and multiplying it by 170. This concept is sort of like a unit cost concept. If you're ever comparing two different things, if you're ever in a grocery store and want to figure out which is a better deal, should I buy 200 grams for $3 or should I buy 500 grams for $7? Which is the better deal? Well, one of the ways that you find out which is a better deal is you find out how much 1 costs, or how much 100 grams costs. Or you cheat and look in the store where they say 100 grams costs this much, and you don't have to do any math whatsoever. Right? Have you noticed that in a store, that some stores have that? So if I divide by 180 on this side, that means on this side 1 degree is pi divided by 180. And then 170 would be 170 times this, so I'd get 170 pi over 180. And I did the same thing on this side. I divided by 180 and then I multiplied by 170. Say that again? Any radian. Well, and that's what you could do, right? Some people remember this. Some people say, I remember that 1 degree is pi over 180 radians. I'll just add radians right now. And so if I want to find anything in degrees, all I have to do is multiply by pi over 180. Right? If I want to find 32 degrees, well, it's 32 times pi over 180. If I want to find 78 degrees, 78 times pi over 180. The only problem with this technique is you can use the same thing for doing degrees to radians or radians to degrees. Sometimes you're going to multiply by pi over 180. Sometimes you're going to multiply by 180 over pi. They're very similar. They're easy to mix up. So if you're afraid, you're like, oh, which one do I do? This idea always gets you the right, because it's based on a concept. Do I know I can get down to 1 and then get from 1 to 170? And you can use this with figuring things out on both sides. So this is our answer. And again, you wouldn't have to reduce this fraction. Even though it's 17 pi over 18, that would be right as well. You could leave it as 170 pi over 180. And if you go to your calculator and you want to know what the decimal is, 170 pi divided by 180, it's 2.97. This is exact. I guess here I should practice those squiggle brackets. That's an approximation. So we have an exact values and we have approximations. Now, the second one. Given negative 12 pi over 11 radians, we want to sketch that angle and determine its measure to the nearest tenth of a degree. So I'm going to ask you a question. What quadrant is negative 12 pi over 11? Does your brain tell you the answer right away? Or do you have like, oh. If I asked you in something in degrees, What quadrant is negative 120 degrees? It's negative. Still have to think a little bit. It'll be quadrant 3, right? Because it's negative going around in the negative direction, it'll end in quadrant 3. But thinking in radians, you're not used to, so it's going to be harder. How do we go about doing it? Well, you could change this to degrees, right? That would be one strategy. I'm going to change negative 12 pi over 11 to degrees, and once I figure that out, I'll be able to draw it because I know how to draw degrees. But we're going to want to be able to draw radians directly. So I'm going to first teach you how to do that, and then we're going to convert it to degrees after. I'm going to erase this. Part B, we're going to sketch our angle. Some things to know about angles. All the way around the whole circle is 2 pi, right? Halfway around the circle would be pi. 90 degrees would be pi over 2. And 270 degrees would be 1, 2, 3 90 degrees, so it would be 3 pi over 2. And what we're going to do is think of things in portions of pi. Pi over 2, can you see that that's half pi? This is 1 pi. This is 1.5. That's 2. So when I look at 12 over 11, bigger than 1 or less than 1? Bigger than 1. Bigger than 1.5 or less than 1.5? Less than 1.5. Somewhere between 1 and 1.5. Okay? So somewhere between 1 and 1.5, if I was thinking positively, can you see that that would be in quadrant 3? But since we're going in the negative direction, it'll be in quadrant 2, which is the third negative angle. And that's where negative 12 pi over 11 would be. If you want to be really exact in your thinking, the fact that we have an 11 here, you would imagine between 0 and pi cut into 11 equal pieces. And we're just going 1/11th past to get to 12. So there's our angle drawn correctly. Part 2, if we wanted to figure that out, again, if we use radians here, well, we always did degrees here, didn't we? Just being consistent. Degrees over here, radians over here. What do we know? We know 180 degrees is pi radians. So we could figure out what 1 is by dividing by pi. And then we could figure out what negative 12 pi over 11 is by multiplying 1 by negative 12 pi over 11. Does that concept make sense, what I'm doing? I'm figuring out what 1 is, and then I'm using that 1 to figure out anything after that. Yes? Oh, well, these from here to here, this is a divide sign. Yeah, it looks a little bit messy. I'll write it nicer. Divide by pi, right? Does that make sense? To get from pi to 1, we're going to have to divide by pi. And then here, I didn't add the multiplication sign. There, we have to multiply 1 by negative 12 pi over 11. We do the same thing on this side. We divide by pi. That will give us 180 degrees over pi. And then multiplying by negative 12 pi over 11, it's not really nice numbers, but you would have 180 over pi multiplied by negative 12 pi over 11. Can you see that the pi's will simplify? Sorry, say that again. Because that is the angle that we're trying to find, negative 12 pi over 11. And then these pi's will simplify, and you have to do 12 times 180, which is what, 1440? No, it's more than that. What is 12 times 180? 2160, yes. So you would get negative 2160 divided by, excuse me, 11. And you could go to your calculator and get an approximate value for that. This is degrees, so we need to make sure that this is our degrees sign. Now, with changing from radians to degrees, again, some people are going to remember this. Some people are going to remember 1 radian is 180 degrees over pi. So if I want to find anything else, I can multiply by 180 over pi. If you want to use that, that's great. Okay, if you want to use this technique, that's great. A shortcut technique for changing radians to degrees when pi is involved. So notice that we started with negative 12 pi over 11. And you know that pi radians is equal to 180 degrees. So all you need to do is change that pi radians to 180 degrees, and you'll get your answer right away. But that technique only works when you're changing radians to degrees and you have pi in the question, because it's a direct switch that I know that this and this are equal. Did we finish all of part B? Well, to the nearest tenth, so we do need to go to our calculator. 2160 divided by 11, 196.4. This is actually good. Again, use those squiggle brackets. Does our negative sign, does our drawing match negative 196.4? Yes. So our sketch seems to match what we figured with degrees. Part C, given 7.5 radians, find out how much that is in degrees. So I'm going to erase this part here and this part here. Notice this would be one you wouldn't be able to use that shortcut because there's no pi in. It's not 7.5 pi radians, it's 7.5 radians. And the number one, because there's no units with radians, sometimes students think that the pi means radians. It doesn't. You can have pi degrees. And so with this one, we can't use the shortcut. How would I get to 7.5? I'd have to take this and multiply it by 7.5. So I would do the same thing on this side. And 7.5 radians equals 7.5 times 180 over pi, which is approximately, we need to the nearest tenth, 7.5 429.7. You know how earlier I said, imagine jumping up in the air and turning 180 degrees? Yep. Imagine jumping up in the air and turning 180 radians? Well, let's change 180 radians to degrees. Wow. 10,000 degrees you'd have to turn. Wow. If we divide that by 360, because there's 360 degrees in one full turn, 28.6 turns. If you could jump and do that, you would break records in all sorts of things. And probably break bones. Yeah. You can just imagine someone going off a ski jump, spinning that way too. Excellent. Okay. Questions are 4, 5, and 7. I think that's it. We'll work on those.